There is a piece of video from Friday night that I have now watched more times than I can reasonably justify. It is not the launch. It is not the plasma. It is a shot of a 52-meter stainless steel spacecraft, lying on its side in the Indian Ocean west of Australia, floating, intact, in one piece, still transmitting high-definition video back to Earth from the surface of the water. That had never happened before. Every previous Starship that reached the ocean exploded, broke apart, or tipped over and tore itself open. On Friday, Ship 40 came down through the atmosphere, flipped, lit its engines, settled onto the waves, rolled over, and just stayed there. Filming, SpaceX's Dan Hewitt, calling the flight live, described it as their softest splashdown ever. At Starbase, and at the company's factory in Hawthorne, California, you can hear the moment on the live stream when people realize the ship is not going to explode. But that is not the footage I actually want to talk about, and it is not the reason this flight is worth your time. Before Flight 13 launched, SpaceX went out to the vehicle and painted some of its heat shield tiles white. Not for decoration, not for branding. They painted a scattering of tiles white, so that, from a distance, they would look like gaps, like tiles that had fallen off. And then they loaded 6 satellites carrying high-resolution cameras into the payload bay, launched the whole stack, released those satellites in space, and had them turn around and photograph the ship to see whether the fake damage was visible. They faked damage on their own spacecraft so they could find out what real damage would look like from orbit. In the next 30 minutes, I'll walk you through every significant piece of footage from this flight in order, and explain what you're actually looking at in each one. The abort that stopped the countdown at 0. The dispenser that shoots satellites out sideways. The clip filmed from a back garden in South Africa. The reason the plasma is 6 different colors. The buoys that solved a problem spaceflight has had since the 1960s. And the shot of the tiles at the end, which is the one the engineers actually care about. Some of this is spectacular. Some of it looks like nothing and matters enormously. I'll tell you which is which. Let's start with the white tiles, because they are the key to the whole mission. Starship's heat shield is made up of roughly 18,000 individual hexagonal ceramic tiles, bonded to the steel skin of the vehicle, covering the windward side, the belly, the surface that faces into the airflow during re-entry. Each one is a separate component. Each one has to stay attached through launch vibration, through the acoustic hammering of 33 engines, through the aerodynamic loads of ascent, through hours in vacuum, and then through the most violent thermal environment a vehicle can experience. The space shuttle had a similar problem and never fully solved it. Its tiles required inspection and frequent replacement after every flight, which is a large part of why the shuttle never came close to the turnaround times it was sold on. For Starship, the problem is worse in one specific way. SpaceX wants to catch these vehicles back at the launch tower. That means someone, sitting at a console, has to decide whether the heat shield is intact enough to bring the ship down over land toward a tower with people and infrastructure around it, or whether to ditch it in the ocean. You cannot send anyone up to look, so you have to photograph it from outside. That is what the 6 satellites were for, and the painted tiles are what makes the test meaningful, because an inspection system is worthless unless you know what it fails to see. If you photograph a perfect heat shield and the pictures look fine, you have learned nothing. You don't know whether your cameras would have caught a problem. But if you deliberately create targets that mimic missing tiles at known locations, and then check whether they show up in the imagery at the resolution and lighting and angle you actually get in flight, now you have calibrated the instrument. It is the difference between taking a photograph and testing a camera. Flight 13 also carried something else in the shield that produces no footage at all and is arguably more important. Some of the tiles were fitted with embedded sensors, load sensing tiles, designed to measure the mechanical forces acting on the vehicle during ascent, on a flight that deliberately pushed through higher dynamic pressure than previous ones. The attachment method itself had been revised, with improved pins holding the tiles down. So the heat shield on this flight was simultaneously a shield, an experiment, a sensor array, and a photographic target. Keep that in mind, because it reframes almost every shot that follows. Now, the footage from the 8th of the month that most people skipped. The first launch attempt was on the 16th of July, and it reached T-0. If you watch that clip, you see the countdown complete, you see ignition begin, and then you see it stop. The flight software triggered an automatic abort at the last instant, because 4 Raptor engines had failed to meet acceptable starting parameters. I want you to appreciate what is happening in that clip, because it looks like a fizzle, and it is actually one of the more impressive things in the whole sequence. Starting a Raptor is a controlled detonation that has to occur inside a very narrow envelope. Turbopumps spin up to enormous speeds, propellant flows have to stabilize, chamber pressure has to build along a specific curve. All of this is happening across a large number of engines simultaneously, at the base of a fully fueled 407-foot vehicle, standing on a launch pad that took years to build. 4 of those engines came up outside specification, and in the fraction of a second available, the software noticed, evaluated, and shut the whole thing down, saving both the rocket and the pad. There is no drama in that footage. Nothing moves. That is the point. A vehicle that lifts off with 4 engines outside their start envelope has a spectacular problem somewhere between the tower and stage separation, and the footage of that would be a great deal more exciting and considerably worse for everyone. Then weather intervened. The second attempt was scheduled for the 20th, moved to the 23rd, then to the 24th, because Tropical Storm Bertha was sitting in the Gulf. On Friday the 24th, at 6:51 in the evening Eastern Time, it went. The liftoff footage is the most familiar kind of shot in the whole flight, and it is still worth slowing down for, because the scale is difficult to convey. The full stack stands 407 feet, around 124 meters. That is taller than a 30-story building, and the whole thing leaves the ground on a column of flame from Raptor engines burning liquid methane and liquid oxygen. The detail worth watching for on this specific vehicle is the exhaust. Methalox burns remarkably clean compared to the kerosene-fueled rockets most people picture. There is no thick black smoke. The plume is a bright, almost translucent blue-white at the base, and the enormous cloud you see rolling across the pad is not exhaust at all. It is water vapor from the deluge system, hundreds of thousands of liters dumped onto the pad to absorb the acoustic energy. Without it, the sound reflecting off the concrete would shake the vehicle apart. Booster 20 was the second Block 3 Super Heavy to fly, and if you compare it to earlier footage, you can see the differences. It carries Raptor 3 engines. The interstage is integrated into the structure, rather than being a separate section, and there are 3 grid fins instead of 4. That last one is worth a moment. Grid fins are the lattice-looking panels near the top of the booster that steer it during descent by biting into the airflow. Going from 4 to 3 is not a cosmetic change. It removes mass, removes a mechanism, removes an actuator, and removes a failure mode, while requiring the remaining 3 to do the same job. That is the signature of a design maturing. You stop adding things and start removing them. Next, stage separation. Starship uses hot staging, which means the upper stage lights its engines while still attached to the booster and pushes itself off. Most rockets separate first and light second. SpaceX does it in the opposite order because it avoids the fuel settling problem you get in the moment of freefall between separation and ignition. On camera, this is one of the best shots of any launch. You see the ship's engines ignite inside the interstage, fire directly into the top of the booster, and the 2 vehicles push apart in a burst of flame between them. Then Booster 20 performed its boost-back burn, flipping around and firing to reverse its trajectory toward the Gulf, and it did so cleanly. Hold on to that, because the booster story ends differently. Now the payload bay, and the shot that produced the loudest noise on the live stream. Starship does not deploy satellites the way a conventional rocket does. There is no fairing that splits apart. Instead, there is a long slit-shaped door in the side of the vehicle, and the satellites are pushed out sideways through it, one after another, in a continuous sequence. SpaceX nicknamed it the Pez dispenser, and once you have seen it, you will never call it anything else. On Flight 13, it released 20 Starlink version 3 satellites, and every single one came out. 20 for 20. This was the first time in Starship's history that the payload was real. Every previous flight that used the payload door carried mass simulators, dummies built to the right shape and weight with no electronics inside. On Friday, it was functioning hardware, and the difference in what you're watching is total. Those objects sliding out of the side of the ship are not test weights. They are working satellites, and within minutes they began unfolding solar arrays and antennas, and attempting to establish contact. The audio on the live stream during this sequence is worth listening to on its own. You can hear SpaceX employees at Starbase chanting and cheering each time another satellite emerged. And the satellites are not incidental to this story either. The version 3 units are a generational jump, designed for downlink on the order of a terabit per second each, more than 10 times what the current V2 mini satellites manage, along with improved direct-to-device capability aimed at connecting unmodified phones. SpaceX now operates more than 10,000 Starlink satellites, the largest constellation ever assembled by a wide margin. All 20 on this flight were on a trajectory that would bring them down again along the same path as the ship, because the whole flight was deliberately suborbital. They were sent up to prove the dispenser, prove the satellites, and take photographs. Then they came home. Which brings us to the strangest footage of the entire mission. After deployment, the 6 camera-carrying satellites turned and looked back at the vehicle that had just released them. Think about the geometry for a second. You are a satellite. You have been shot sideways out of a slot in the side of a spacecraft. You unfold, you orient yourself, and then you point your cameras back at the enormous steel object drifting away from you. And you start photographing its belly, and you beam those images down to a control room on the ground. One of them caught a view of Starship's engines as the ship continued on around the Earth, and the last 2 did something even stranger. They used lights to illuminate the vehicle while it was in orbital darkness. Sit with that image. 2 small satellites, in the shadow of the Earth, shining lights onto the underside of a spacecraft so that engineers thousands of kilometers below could see whether some ceramic tiles were still attached. It is the most mundane possible task, executed by the most extraordinary possible means, and it is a better summary of what modern spaceflight actually looks like than any launch shot. Then there is a clip that did not come from SpaceX at all, and it might be my favorite. Roughly 27 minutes after deployment, Ship 40 relit a single Raptor engine as a maneuvering test. Relighting an engine in vacuum after a long cold coast is a prerequisite for essentially every future mission profile. It is what a deorbit burn is. And it is what a departure burn for the Moon or Mars would be. Somebody in Pretoria, South Africa, filmed it from the ground. An observer with a camera on the surface of the Earth captured the moment a rocket engine ignited in space overhead, and the clip was shared publicly. You can see the point of light change as the engine lights. I find that remarkable for a reason that has nothing to do with the visual. It is independent verification. Every other image from this flight comes from SpaceX's own cameras, on SpaceX's own vehicles, downlinked through SpaceX's own network. This one came from a person with a camera and a clear sky, and it confirms the burn happened, where and when SpaceX said it did. That matters more than people realize for a company whose live broadcasts are also its marketing. It is the difference between a claim and an observation. And now we come to the re-entry, which is the footage everyone has seen and almost nobody has had explained to them. As Ship 40 came down, the onboard cameras beamed back images of the vehicle wrapped in plasma. And the colors in that footage were extraordinary. Purple, pink, blue, yellow, orange, white, all of it moving and streaming past the camera and sheets. Here is what you are actually looking at, because the common explanation is wrong. the vehicle is not on fire. There is nothing burning. And it is not, primarily, friction, despite that being the explanation almost everyone was taught. What happens is compression. The ship is moving through the upper atmosphere far faster than sound can travel in it, which means the air in front of it cannot get out of the way. It has no warning. It gets slammed into a shock layer and compressed violently, and compressing a gas that hard heats it enormously, the same principle that makes a bicycle pump warm, scaled up by an absurd factor. At those temperatures, the air stops behaving like air. Electrons are stripped from atoms and molecules, and what surrounds the vehicle is no longer gas but plasma, a soup of charged particles. And when those particles recombine and drop back down to lower energy states, they release that energy as light, at wavelengths determined by which atoms are involved. That is why the colors are not random. The atmosphere is mostly nitrogen, and excited nitrogen emits strongly in the blue, violet, and pink part of the spectrum. That is where the purples and pinks come from. Oxygen contributes its own lines, and the yellows, oranges, and whites are largely thermal, the glow of the vehicle's own surface, and the hottest regions of the shock layer radiating like anything else heated until it shines. So the light in that footage is a spectrum, and a spectrum is data. The colors in a re-entry video are, in a rough sense, a chemical readout of what is happening around the vehicle. When engineers see colors that don't belong, a flash of something unexpected, that can indicate material coming off the ship and vaporizing in the flow. Watch that clip again knowing that, and it stops being pretty and starts being informative. During the descent, Ship 40 also did something new. It performed a dynamic banking maneuver, deliberately designed to mimic the trajectory a future ship would fly returning to Starbase. This is one of those things that looks like nothing on camera and represents an enormous amount of engineering. The ship steers using 4 aerodynamic flaps, 2 forward, 2 aft, which it moves into and out of the airflow to control its attitude. It is essentially falling belly first through the atmosphere, and using those flaps like a skydiver uses their arms and legs, except at hypersonic speed with plasma streaming past. By banking, the vehicle changes where it ends up. That is how a returning ship would eventually steer itself toward a specific point on the Texas coast, rather than simply landing wherever physics dropped it. On Friday, it used that capability to guide itself precisely to a target zone in the Indian Ocean. And what was waiting at that target zone is technically the cleverest thing on the entire flight. SpaceX had deployed a network of buoys, fitted with Starlink terminals, positioned to capture the final phase and provide continuous video. To understand why that matters, you need to know about the blackout. Since the earliest crewed spaceflights, re-entry has come with a communications blackout. That plasma sheath surrounding the vehicle is electrically charged, and it interferes with radio signals passing through it. For decades, this meant that during the most dangerous phase of a mission, the part where things actually go wrong, mission control had no contact. They waited. Apollo crews went silent for minutes at a time on the way home. It is one of the oldest and most nerve-wracking constraints in the business. On Flight 13, the plasma phase was covered. Live views continued through the hypersonic descent, and those live views showed the ship's 6 engines intact, along with its flaps and other systems, all the way down. That is a genuinely significant capability change, and it barely got mentioned. Continuous telemetry and video through the highest risk phase of flight means that if a vehicle is lost during re-entry, engineers have data right up to the final moment, instead of a gap where the answer used to be. Then the landing. Ship 40 executed its flip. Rotating from the belly first descent attitude to a vertical, engines down orientation, and lit 3 engines for the landing burn. Watch the engine count in that footage, because it tells the story. 3 engines, then down to 2, then down to 1, throttling back as the vehicle sheds the last of its velocity. That stepping down is not a malfunction. It is exactly how you land a vehicle that has burned off almost all its propellant. The ship is far lighter at touchdown than it was at the start of the burn, so the thrust needed to hold it up drops continuously. Rather than throttle 3 engines down into an inefficient and unstable regime, you shut them off in sequence and let the remaining engines work in the range where they behave predictably. And then it settled onto the water, and toppled over onto the waves, and stayed in one piece. This is the moment I opened with, and I want to explain why the reaction on the live stream was what it was. Starships that reach the ocean tip over. They have to. They land vertically on water, which does not hold them up. Every previous time the vehicle has come apart on tipping, usually violently, because a mostly empty stainless steel tube full of residual cryogenic propellant that falls sideways onto water at speed does not survive the impact. On Friday it did, and because it survived, it kept transmitting. High-definition imagery from the surface of the Indian Ocean of an intact starship lying on the water. Dan Hewitt called it their softest splashdown. He also noted it was the first time they had actually put a starship into the water rather than losing it, and framed it as the outcome the heat shield team had been hoping for. Which brings us to the final shot, and the reason all of this was worth doing. For the first time, SpaceX has clear views of a Starship heat shield after a full re-entry, with the vehicle intact. Every previous flight either ended in breakup or ended with the vehicle destroyed on contact, which meant the shield could be studied only through whatever imagery survived, and whatever inference the telemetry supported. Now there are pictures of the actual tiles, after the actual heat load, on a vehicle that is still in one piece. Combine that with the 6 satellites that photographed the same shield from orbit, and the painted white tiles that gave those cameras known targets, and the embedded load sensing tiles that recorded the mechanical forces during ascent, and you have something SpaceX has never had before. The same heat shield documented from outside in space, instrumented from within during flight, and photographed intact afterwards. That is what Flight 13 was actually for. Not the satellites. Not the spectacle. 18,000 ceramic hexagons, and the question of whether you can trust them enough to bring one of these things down over land. Now the part of the footage nobody has replayed, because there is nothing to replay. Booster 20 died. After its clean boostback burn, it came down toward its offshore point in the Gulf and attempted its landing burn. Only 10 Raptor engines relit, and 2 of those shut down within seconds of ignition. The booster hit the water considerably faster than planned and was lost. There is no triumphant footage of that. There is no shot of a booster floating intact. And it matters, because this is the second flight in a row with propulsion problems in that phase. SpaceX had made specific hardware and software modifications after Flight 12 to address engine-out issues on the landing burn, and on Flight 13, the problem appeared again. A landing burn has no margin for a late diagnosis. The vehicle is falling, the burn is calculated around a specific amount of thrust arriving at a specific moment, and every engine that fails to light removes a slice of the deceleration budget at the exact point where there is no time to compensate. So the honest summary of the visuals is split. The ship's footage is a series of firsts, several of them genuinely historic. The booster's footage ends with a splash and a data package. Let me be clear about what this flight does and does not prove, because the imagery is seductive and it is easy to overread. An intact splashdown is not the same as a successful landing. The ship came down in water under conditions chosen to be forgiving and then fell over. Catching one at a tower is a substantially harder problem. Surviving one re-entry is not the same as a reusable heat shield. It is one flight, one thermal profile, one set of conditions. Reusability means doing it repeatedly without teardown, and that has never been demonstrated by anyone. And a suborbital flight is still a suborbital flight. 13 flights and 3 years in, Starship has not completed a full orbit of the Earth. That is a deliberate choice for range safety, not a failure. But everything that comes next, propellant transfer, long-duration operations, departure for anywhere, happens in orbit, and the program has not yet crossed that line. Here is what I'll be watching in the imagery from the next flight. The first is the heat shield photographs themselves. Watch for whether SpaceX publishes anything about how the white painted tiles appeared in the orbital imagery, because that determines whether their inspection method actually works. The second is the landing burn on Flight 14. Count the engines. 2 flights in a row with relight problems is a pattern, and a clean burn would be the clearest possible signal that the modifications finally took. The third is any attempt at a return to launch site rather than an ocean splashdown. SpaceX will not try that until the imagery convinces them the shield holds, so the first time they announce it, that is the answer. The fourth is whether a flight goes fully orbital, that is the gate, and everything downstream waits behind it. And the fifth is whether they recover anything physical from the water. A floating ship is a ship that might be reachable, and actual tiles in an engineer's hands beat any photograph ever taken. I want to end where I started. There is a shot from Friday night of a stainless steel spacecraft lying on the surface of the Indian Ocean, west of Australia, at night, in one piece, filming itself. It has just traveled to the edge of space, released 20 working satellites through a slot in its side, relit an engine in vacuum over southern Africa, while somebody in a garden in Pretoria pointed a camera at it, fallen back through the atmosphere wrapped in pink and violet plasma, steered itself with 4 flaps to a set of buoys in the middle of an ocean, flipped upright, lit 3 engines, stepped down to 1, and settled onto the water without braking. And the reason anyone at SpaceX cares is that somewhere on its belly there are a handful of tiles that were painted white before launch, and the question is whether the cameras could see them. That is the whole flight. Everything spectacular in it was in service of a question about paint. We'll be watching Flight 14.